Episode 7. Let me summarize what we have done so far. We simply took 2 by 8 rectangle and drove a quadratic equation. We then developed a general quadratic equation representing any rectangle of shape A times B. The solution for this equation we wrote as x is equal to r plus minus under root r square minus ab, where r is equal to a plus b by 2 divided by 2. Rearranging, we take the r on this side, x minus r is equal to plus minus under root r square minus ab, and now squaring on both and square on both sides, we'll get x minus r whole square is equal to r square minus ab. Now here we take this term minus ab on the other side, on the left hand side, and since it is a rectangle shape, we took a under root and then square it to make it compatible with the Pythagoras theorem. So there is this square, x minus r square, and then under root ab square is equal to r square. This is Pythagoras theorem in detail. What it exactly says is, if you measure areas in unit squares and disregard their shapes, then adding two squares always yield a third one. It has deeper consequences. For example, if you have solved the geometric quiz in episode 4, you might have noticed it has no familiar shape, but the volume it contains is exactly that of a sphere of radius r. It is because of Pythagoras theorem that we transform all elliptical areas into equal circular areas. This is areas. With that in mind, I drew the following circle. This is the circle I drew, and the radius of the circle is r. The length of A starts from one end on the diameter, this from one end to somewhere on the diameter, and the B is the rest of that. So A plus B is always 2, or R, in this case R, and then we can represent this one in a geometric form by taking angle theta, and this is the angle, this is the radius. So I'll explain to you in the next episode what I meant by this one, but this is what I have done so far. Now back to with that in mind, I drew the following circle. This is the circle I showed. So this is the same circle. If you pay a closer look at the equation, x minus r whole square minus r square minus ab is equal to 0, you will notice that it is a depressed quadratic equation. By depressed, it is meant because this has a square. It's a second degree polynomial equation with x square term but no x term in it. So the solution is very easy for this one, because this is a square term. We can further simplify it by reducing the circle to unit circle, or r is equal to 1. So in this case I am making r equal to 1. So since r is a variable, so to just specific it, make it to just radius 1. So that is x minus 1 square is equal to 1 minus ab. this is equation with apparent solution, because this is the solution, this is a square term on this side. So I will always write this equation in solution form like this, and I will call this solution as equation 2. Or in a trigonometric form, it can be written as x minus 1 is equal to plus minus cos theta. So if you come down onto the picture of circle, this is plus minus, this is a cos theta here from the center to this point. Now back. Now all we need to represent any rectangle slash ellipse is just one variable, which is theta, or in other case it could be b. Yes, just one variable. This makes our life so easy. To emphasize the importance of this equation, I would simply say that if we extend this reasoning to include third degree polynomial, the solution will be single equation, and this is the single equation. If you come down here, so this is the for the cube, this is a unit quadratic equation, and this is the solution for unit cubic equation. We can write the unit cubic equation as x minus, and then triple bars here, triple bars plus minus cos theta, comma plus minus pi by 3. This what I mean by this is, the first one is x minus 1, so this triple bar can be divided into two equal signs. X minus 1 is equal to plus, this top plus sign is here, means cos theta. So the first root of this cubic equation will be 1 plus cos theta, one root is the first root. The second root, we will take the minus sign, this bottom minus sign here, and then cos theta, and we take away the comma now, because, and then we put plus minus, this plus minus sign here, and then this we will further divide into two portions. X is equal to 1 minus cos theta plus pi by 3, and the other one is x is equal to 1 minus cos theta minus pi by 3. So we got all three roots here for the cubic equation. So I am coming back. Historically, one of the greatest battles fought in mathematics was over the solution of cubic equation. This shows the complexity of the problem. Complexity in mathematics increases sharply with the increase in variables. So our objective here is to reduce variables, and that's why we are working with a unit circle. So we are not dealing with r no more. We are just put r is equal to 1. We are taking only one circle with radius r is equal to 1 to represent all circles. There are so many advantages in taking this approach. It not only helps in math but also other disciplines too. For example, if we only know the entire surface of the earth, we can then extend this knowledge to other planets, such as we do not have to rename the surface of Mars. We just have to draw a prime meridian and give exactly the same names to each region on Mars as of Earth, with same latitude and longitude coordinates. For example, a place Washington DC on Mars, a place called Washington DC on Mars, would also be 38.92 north and 77.04 west. It would then be conceptually clear that what would we mean. So if somebody says traveling from Washington DC to Sydney on Mars, one would clearly understand where the Sydney would lie on Mars and where the Washington, because all the names on the Mars are exactly the same names on Earth. So the conceptual, it will So we are working on one unit planet, which is Earth, and then we extending that information to other planets with other radius r. So it will be always easier to work on unit sphere and then extend that knowledge to the other spheres. NASA, please give heed to this suggestion. We want to know about different parts of Mars with the knowledge we already have about Earth. This is what x minus 1 in the above equation says. Thank you.